So here we have to explain the concept of the elementary operations of a matrix and the theorems on inverse of a matrix. So now there are three elementary operations. There are three elementary operations or called as transformations of a matrix. Transformations of a matrix. So the first one is the interchanging of any two rows or any two columns. Interchanging any two rows or any two columns of a matrix. Suppose, for example, if we have the matrix A, which is 1, 2, 1, minus 1, root 3, 1, then 5, 6, 7. And then on this matrix A, we apply the operation, we apply the elementary operation, which is R1 is interchanged with R2. So it means the first row will change into the second row and second row will go to the first row. So therefore, the transformed matrix, suppose I call it as A dash. So no, it is not A dash. A dash means A transpose. So let's call it as B. Therefore, the matrix B, which is the transformed matrix A. So that will be second row will go to the first row. So it will be minus 1, root 3, 1. And one first row will go to the second row. So 1, 2, 1, and 5, 6, 7. Then the second elementary operation is the multiplication of the elements of any row or column by a non-zero real number. The multiplication of the elements of any row or any column by a non-zero real number. So suppose, for example, if you have the matrix B, which is equal to 1, 2, 1, minus 1, root 3, 1. And then on this matrix B, we apply the elementary operation where C, the third column means C3, goes to 1 by 7 C3. So it means all the elements in the third column should be multiplied by 1 by 7. So then we will get, suppose the matrix D, suppose. So suppose we tell it as the matrix D. So that will be 1, 2, 1 by 7, minus 1, root 3, 1 by 7. Okay. Then the third elementary operation is that the addition of the elements of any row or column, the addition to the elements of any row or column, the corresponding elements of any other row or column multiplied by a non-zero real number. So it means that so the addition of the elements of any row or column, the addition to the elements, the addition to the elements of any row or column, the corresponding elements of any other row or column, of any other row or column, multiplied by a non-zero real number, multiplied by a non-zero real number. Non-zero real number. So suppose we can understand this by one example, that is, suppose we have the matrix C. C is 1, 2, 2, minus 1. And on this matrix C, we want to apply the elementary row operation, that is R2 goes to R2 minus 2R1. So it means that the elements of the first row are multiplied by minus 2, and then that those are added to the elements of the second row. So then we will get the matrix E, suppose matrix E, that will be equal to so the first row will remain unchanged and the second row will go to, so 2 minus, so R2 minus 2R1, so it is 2 minus 2, that is 0, and minus 1 minus 4, it is minus 5. So this is the required transformed matrix. Okay. Then we shall understand the concept of invertible matrices. Invertible matrices. So the rule is that if A is a square matrix, A is a square matrix of say order n, suppose, and there also exists another matrix B, and there also exists another matrix B, such that A into B, that is equal to B into A, that is equal to the identity matrix I. So then the matrix B is called the inverse of the matrix A. Then B is called the inverse. B is called the inverse of the matrix A, and which is denoted as B equal to A inverse. And so which is denoted as B equal to A inverse. Okay. Okay. So if A inverse exists, then we say that the matrix A is an invertible matrix. Then we say that the square matrix A is invertible. Then, so based on the inverse of matrices, there are two theorems. The first theorem is that the inverse of a square matrix, if exists, is unique. The inverse of a square matrix, if exists, is unique. So This theorem is also called as the uniqueness of inverse. Uniqueness of inverse. Then the next theorem is that if A and B are invertible matrices of the same order, if A and B are square matrices and invertible matrices, A and B are invertible matrices, A and B are invertible matrices of the same order, then we can say that AB whole inverse, that will be equal to B inverse into A inverse. Then okay, so we shall understand these concepts of inverse of a matrix by some solved uh, by the help of suitable examples i- in the subsequent videos. So there is a rule that is the inverse of a square matrix. The inverse of a square matrix can be obtained by using the elementary row operations or elementary column operations. Can be obtained by either elementary row operations or elementary column operations, which we shall understand by some suitable examples in the subsequent videos. Thank you.